Hello everyone. Thank you for joining us on the Aplaudo Development Conference 2025 edition. Today, I will be your host. My name is Saul Parada. I work here on Aplaudo as a QA automation engineer. Today, we'll be talking about Beyond the Script, harnessing AI agents to drive 30% more efficient QA. For that, let's start with a simple question. Can you relate? I'm pretty sure that if you have been working on the QA area for a long time, or if you are starting, you are going to identify yourself with one of these scenarios. First, let's see, creating and maintaining detailed test plans. This is a task that is hard at the start and it can be later on difficult to maintain, especially since the requirements are changing all the time, and once we start the project, we only have one set of goals in mind in that moment. Then, writing repetitive test scripts for every scenario. I can say I have lived this, and I'm pretty sure that I'm going to continue live this scenario for a long time. This can change regarding the approach that you're following. Maybe you don't have to write multiple scenarios, but it's pretty nice to have a tool that will allow us to think on all of these with a simple prompt. Then, manually performing regression tests after every code change. Yes, this is a reality. Some teams still need to perform manual regression. Maybe they don't have a test automation suite in hand, but with the power of AI, we'll be able to create one from scratch. On the demo site, we will see how we can create it for a simple login page, but I'm going to save it for later because those will be a little bit of a spoiler. Now, tracing and documenting the bugs we did the reproduction step. In this case, when we're testing, we need to create a documentation. When we try to do this using an AI, it's going to give us the step-by-step on how to reproduce the data that was produced and all the details that we pass. Staying up to date with new tools and framework, this is a reality. If you can see how we have changed from the starting of LL models to now agents, is a chip that is going on the market. We can see that test automation tools like Cypress, Playground, Selenium are making the shift. In this case, Selenium and Playground has launched their own MCP server that is going to allow agents to continue improving the test automation world. Rerunning flagged tests that fail immediately? Yes. Some tests are going to fail, and it's important to be able to identify what was the cause of this one. For that, we can use AI to see what was the issue and prepare us a report, and we can later on decide, okay, let's fix it by our side or let AI to fix it. Generating, releasing, and diverse test data. For this approach, we know that we can think about different scenarios. We can say, okay, for this field, I'm going to try a name, a last name, but what will happen if we send special characters, numbers? We can set the AI to provide us all of these values and then replace it on the test. Instead of we providing each of these cases, we have a set of data that we can use. And troubleshoot the broken test scripts when the AI element changes. This is part of the how AI works, that it creates reference and they can later use it to see if any element on the page has changed, and they can use snapshot, compare it, and update it. Now that we have all these questions in mind, let's jump to the other one, where the agents comes in. Okay, writing repetitive test script. In this case, we can use tools with Copilot and the agents. In this case, we're going to use the large language model to send our prompt, in this case, our test scenarios, and say, okay, we want to create a test scenario for a form. Please check all the positive scenarios and negative scenarios. And we can set the guidance here. The large language model is going to be the brain. It's going to take all of this and generate all the test scenarios that we need. Manually performing regression tests. In this case, if the project that you're working doesn't have any part of automation, in this case, we can come here and create a test automation framework from scratch. In this case, we'll need to create first the prompt. In this case, the prompt will be, okay, I want you to go to this website and perform the following steps and create a record of this using, in this case, for example, JavaScript. And we're going to set this files for regression. Once that you pass the prompt, the agent is going to go to the website, perform all the actions that the user will do, and then we're going to get our output that is going to be called generating realistic and diverse stage data. As you know, we're using large language models. In this case, you can see it's a large database that they are trained. Instead of just relying on our own intention, we can go and ask it, okay, I want you to think for this scenario that you are someone from China, you are someone from UK, you are someone from United States. Can you give me some data that is really proper of them? Maybe some language barrier can help us here. Now, the parts that is already been implemented, and I spoiler a little bit, is the troubleshooting of broken test scripts. In this case, with the part of self-healing test. As you know, the project is going to change a lot of times. Maybe we expect some changes, other ones we don't. And in this case, when we run the test, we're going to see that a locator is going to broke. This may be because the parent locator is no longer there. They change the class. Instead of we having to go and manually replace the test or verify where it was broken, we can let it run and it's going to detect that the test failed and it's going to say, okay, the last snapshot I had was this one. Now let me take a new one and compare both of these one. Once we do this, we're going to see, okay, there is a mismatch here. Now we're going to grab the new locator and update it on all the locations. Now let's see how this looks in a workflow. We can take this as the steps that we need to follow. In this case, is the input. We need to provide our large language model with a requirement, user story, a bug, or in this case, a data or a request. Then we need to have the tools. In this case, we'll be using Visual Studio Code, Playwright, and GitHub Copilot for the demo of today. And we need the part that is going to provide the actions. This is going to be a combination of the large language model that is provided. In this case, we are going to use OpenAI, and we're going to use the agent. We're going to enter in more details of how the large language models, the agents, and the tools work all together. But this part of the action is the brain and the body. What will be the output? In this case, we're going to get automated test case, bug reports, and it's going to increase our test coverage for each new test scenario that we provide and is generated. Okay, now let's see what advantage does AI provide for us. In this case, we have increased velocity. We can create faster test scenarios because we only need to go to the website and say, okay, as a user, I need you to go to the login page. You need to add your credentials. And once that you are able to validate that this information has been added, you're going to be sent to the next page. On that page, you need to add the validations that everything has loaded. So instead of us having to go to the website and check, the AI is going to use the agent and validate every element by taking the snapshots. If we increase the coverage, it's going to take time for the request to be completed, but it's going to think and add multiple test scenarios at once. Improve quality. AI can help us to think outside the box. We can go and ask for a request, say, okay, we need to add invalid scenarios. I think about sending invalid data. What about if the data that I send, I just imagine it is, there is no scenario for it, how it's going to behave. Instead of us having to think about this, we can let the agent go, search the data, and use it. Then focus on a strategy. Since AI can help us to create test cases instead of us thinking about what part of the code needs to be fixed, the script that we need to develop, we can let the AI run and focus our time in another task that has high priority, or we can just stay there and see the results and be managing the results. Enhance collaboration. In this case, we can use Copilot and other tools to verify the PRs. We can set a guideline or a baseline for each request and say, okay, I create a new part of the code, let me submit my changes, and it's going to do the validation. If we pass all of these standards, we're going to say, okay, we're able to merge. If not, we're going to get a review, say, okay, before we can merge this, you need to address these changes. Instead of having a person going through this evaluation, we can set the AI to do it for us. Now, let's think about the challenges. As any tools, there are challenges. In this case, prompting and context. This is really important because what we submit to the AI is what we're going to get. If we submit a bad prompt, we're going to have bad results. It's going to start iterating for a long time. So we need to be very precise to what we want. We need to set our requirements straight and say that it doesn't need to deviate or think on other scenarios that we haven't provided. If we are not specific enough, it can go and start hallucinating a little bit. So remember, you need guidance, and we're here for that. And now that we mentioned this, is the black box problem. What is this? Because for us, it's a black box. We have right here our prompt that we enter. Then this is the outcome. What happened in the middle, we mostly don't see it because it's the AI going to the website and making their own assumptions. We can evaluate the end result, but we cannot be most of the time on the middle. So it's a little bit of a problem when we start to run it on eternal iterations. We submit an issue, then it goes an outcome, it doesn't respond to anything, so it goes back again to the start, tries again, and we get again a bad outcome. And we can be going all this way on a circle, and maybe we're not going to end here. So in the moment, you need to go and stop it and continue by introducing a new prompt, flakiness and unpredictability. In this case, you can run the same test twice and the result might be different from the first and the second one. That's because the AI will be using different assertions if you don't specify what you're expecting for, or you don't say you need to be this precise, and until you're pretty certain that everything is good, then we can continue. If you have doubt, please ask me so I can provide my input. Now, the funny part, accountability. In this case, if there is a bug that we miss, who is going to be responsible? Is going to be the QA or the agent? This is going to depend according to the strategy that you are following, and is something really individual, because if the process that you're following is that AI should create everything, then even if you detect something is not right, you need to step up. Because as you remember, this is a tool. We are the agents that are using it, so we need to be careful and monitor everything that goes out. And then we have the cost and resource constraint. In this case, depending on the license that you're using or the AI that you have available, the prices can change. If you are not using a service from a third party and you decide to run it locally, in this case, it's going to have a restraint on your devices. So keep that in mind. And now, let's think on what's going to be our next step. If you want to join this journey, I'm going to leave you these little tasks. First, let's start by thinking a task that we want to automate. For that, let's say, okay, let's go to a login page. Let's enter our username and password. We are thinking about this scenario because I'm pretty sure that everyone has stumbled onto this. Now, let's grab our tools and get our hands there. For that, we're going to use Visual Studio Code, Playwright, an MCP, and GitHub Copilot. For that, we're going to think onto a good prompt and send it. This can be like, okay, you need to go to this website as first step, then you're going to locate the username and password field. And for username, you need to send my name, for example, and the password that you set up. And then once those two fields are filled, you can go and click submit or login. Now, remember, this is a learning that is ongoing. We're going to find challenges, and what is going to help us to build confidence is rinse and repeat. You need to keep trying, start getting embedding prompts. Don't be afraid that if you find an iteration, you need to break it, because if you let it run, it's going to keep running in cycles, and we don't want that. Now, let's come onto the demo. Okay, let's jump to the demo. In this case, we're going to start by creating a new folder. Let's name it ADC for this time. We're going to open the file. We can see there is nothing. So now we're going to open on this location, Visual Studio Code. In this case, I already have installed the plugins for Copilot. We can add it here on the extension section. And if you're running the latest version of Visual Studio Code, we can see the MCP server has been added here. We're going to install the Playground MCP server by clicking Browser MCP Servers. Is going to open the website. And in here we can see all the agents mode that we have available. Right now, we're focusing on Playground. So we're going to install it, open on the location, and click install. Now that everything is ready, we can see the Playground, it has been added here, MCP server install, and if we click right here on manage, we can start, stop, restart the server, see the console, where you can see that it's already running since we started. Now let me stop reset so we can see how it looks starting from the start. Okay, start server, we have all our outputs right here. And now what is going to be the part of the brain. If we can see here, we have build with agent mode. We have the part of ask and agent. If we only focus on the ask, we will be only using the part of the large language model. We're not having an agent that is going to be working with the website. For that, we select agent. And here we have the large language model that is going to use. We have GPT, Claude Sonnet, Gemini, Open Mini, but today we'll focus on Claude Sonnet. Now we have everything here, nothing created. We have the chat, and let's start by submitting our first prompt. The first prompt that we're going to use is going to run Playground in headed mode, so we can see it on this run. We're going to this automation practice website and do the login. For that, we're going to pass the username that is a student and the password. Since this is a demo, it's not going to be kept secret, but we should for best practice. But today is a demo. And we added extra information. In this case, we tell it that it doesn't need to add any other best scenario. Let's be más precise, just the one above, because we don't want it to go and think in something else. Now, says, remember, the credentials that we're using is username and password. Now, let's send it. In here, we can see that it's sending the request and it's generating. We wait for the response, and it says, okay, for that we need to install Playground, and we're going to use the browser of Chromium. We're going to say continue. We can see right here that it's accepted. It has created this package JSON. This is now not module. Let's wait for all the dependencies to be installed. While this is being installed, let's remember how is possible this. This is thank you to Playground MCP server, because we have the following structures. The large language model is the brain, the agent is the body, and the Playground MCP are the tools. If we don't have the tools, the agent cannot communicate to the browser. If we click right here, we can see that all of these are the actions that the agent can do. It can click the browser, close it, drag and drop, do a hover, navigate. And our next prompt is here. Let's click on continue. As you can see, when we try to run code, it's going to ask for the user intervention. This is because they doesn't want to run any malicious code. And just as that, you go to the website, add the information, and as we can see, it says perfect. The test has passed successfully, and it gives us the steps that it did. It added a validation, that's good, and it gives us this file. We are going to say that we're going to keep it. Now we have our test. Now let's see what we can do. We're going to set a second prompt, and it's going to say, based on the previous test run, create a JavaScript playwright automation framework. This is going to go and do the following. It's going to create the file so we can run UI and API testing. It's going to use page object model. It's going to store any sensitive data in the environment files. It's going to add a README. It's going to have a requirement test list. And we have the script. So we want to run all the tests, the UI test or API. We provide a structure for all of this. And now let's the AI work. We send it. And we can see that it's starting by creating the pages, the test, we say to continue, it's going to install the dot environment. In here, we can see that files that are being added or changes is kept here just to have a way to track it. We're not doing anything, just letting the agent work. We can see that all of these files are being added. As you remember, when we start this demo, we only had the file space, or it was empty. We installed Playwright MCP server and just pass two prompts, the test scenario and this second one that is creating the test automation framework. In this case, we can see that it's modifying the Playwright configuration. This is a part that gives us the flexibility to keep continue in something else, because while the agent is running, we can focus our mind in different tasks. In this case, if I was working in a different test scenario, I can start write the steps and then just let the code be created and just validate at the end the results. And this is a part of self-healing. As you see, it tries to find a fix for this change. Say, okay, let's fix this by replacing the entire file content. Let's update with our script. Since this is a demo, we can continue this without issue. But if this was a real project, you need to be really careful and see what is being modified. You cannot just accept any change, because it can modify a file that is going to have an impact on the rest of the application. Now that everything is completed, it's going to run the test. And let's cross our fingers to see that if everything passed. Because as remember, this is a black box. We only provide the input. The agent is doing all the work behind the scenes. I cannot see what is happening, just seeing these outputs. And let's see the outcome. It's removing some files. And it's rerunning the test based on the refactor. If everything is good, okay. And right here is what I was mentioning, that we can find this case when it's going to try to iterate one time and another. In this case, you can see that it's going to create a new Playwright configuration file. This is why we cannot just keep it unsupervised. is a good tool, but as any tool, we need to be really careful of what is being generated. It seems that it's able to run, and it at the fix, and it passed the test. Okay, in this case, I encourage you to try to do the same scenario. Remember that you can pause this at some time and check the test to see what was the prompt. If you want to see it again, let me just add a new file right now so you can see. Let's see right here. This first prompt is the one that we use for creating the test scenario. It's right here. As you can see, these are the steps. Now, let me show you the second one. This one is the one that we use to create the test automation framework. And now it's gone, and we can see right here if everything is good. If we want to keep the test, and we're going to say keep it. Now we have all our test automation framework right here. We can see it has the reports, the results, and this will be the conclusion for this demo. Remember, keep trying, be vigilant. If you see that it's stuck in a part, you need to stop the execution and try to provide more details, or you can say if you find a failure or anything that is blocking you, please ask for feedback so I can provide it. Thank you for accompanying me here. Please enjoy the rest of the Plauto Development Conference.